Hi teacher, I hope you are doing well. I will be presenting about characteristic equation of eigenvalue and eigenvector. Okay, let me begin. Theorem 3 shows how to determine when a matrix of the form A minus lambda multiply I is not invertible. Sorry. The scalar equation determined A minus lambda multiply I equals to 0, and it's called the characteristic equation. Then a scalar lambda is an eigen value of an n multiply n matrix A if and only if lambda satisfies the characteristic equation determined A minus lambda multiply I is equal to 0. Okay, I will try to explain it in explanation. Here is our explanation. If A equals to this matrix, we need to find the characteristic equation. For that, we will use this equation and theorem 3. Okay, we'll write this, determine A minus lambda I equals to determined lambda minus 5 minus 2 6 minus 1 lambda minus 3 minus 8 0. Wait, it will be like that. Then the characteristic equation will be like that. Lambda minus 5, there is 2 lambda minus 5, that's why I will write square. Then multiply minus lambda minus 3 and lambda minus 1 will be equal to 0. Also we can expand this equation. I mean, we can write lambda square minus no, sorry, lambda to the 4. Let me write it again. And if we expand this equation, it will be like that. It will be like that. Okay. If A is an n multiply n matrix, then determined A minus lambda multiply I is a polynomial of degree and called the characteristic polynomial of A. The eigenvalue 5 in example 2 is said to have multiplicity 2 because lambda minus 5 occurs 2 times as a factor of the characteristic polynomial. As you see, there is 2 times lambda minus 5, and these are characteristic polynomial of A. So in general, multiplicity of an eigenvalue lambda is its multiplicity as a root of the characteristic equation. Then if A and B are n multiply n matrices, then A is similar to B if there is an invertible matrix P such that P to the minus 1 AP equals to B, or equivalently A equals to P multiply B multiply P to the minus 1. So we can also write Q instead of P in here. Let me write. I didn't write it. In here we can write Q instead of P. So B is also similar to A, and we say simply that A and B are similar. Changing A into P to the minus 1 AP is called the similarity transformation. Then theorem 4, if n multiply n matrices A and B are similar, then they have the same characteristic polynomial and hence the same eigenvalues with the same multiplices. Here is an example for you. The example was like that. Prove if B equals P to the minus 1 AP, then this equation we need to prove that For that, since okay, let me write determined p to the minus 1 multiply determined p equals determined p to the minus 1 multiply p equals determined I and equals to 1. We see from equation I that determined b minus lambda I equals to determined a minus lambda I. And there is something I want to tell you. The matrix is 2 1 0 2 and 1 0 1 2 are not similar. Even so, they have the same eigenvalues. And similarity is not the same as row equivalence. If A is row equivalent to B, then B equals to A E multiply A for some invertible matrix A. Row operations on a matrix usually change its eigenvalues. Then that was my presentation. Thank you for watching. I hope you will understand my presentation. Thank you.